Thailand stands at a turning point in its energy history. As one of Southeast Asia's largest energy consumers, the nation faces a growing challenge in balancing economic development with its commitment to achieving carbon neutrality by 2050. Climate change, water scarcity, and land degradation have become intertwined problems that demand an integrated solution. This study from Dhurakij Pundit University introduces a model that connects climate, land, energy, and water systems combined with the open-source energy modeling system platform. Together, these tools explore how Thailand can transform its fossil fuel-based energy system into a renewable and sustainable future aligned with the 29th meeting of the Conference of the Parties, or COP29, Global Climate Goals. The study has three main objectives. First, to develop a baseline energy pathway that reflects Thailand's current dependence on fossil fuels. Second, to simulate a carbon-neutral scenario through the integration of renewable energy and reforestation. And third, to evaluate long-term trade-offs among energy, land, and water resources while maintaining economic feasibility. By doing so, the research provides strategic evidence to support Thailand's national energy plan and its international climate commitments. Using the climate, land, energy, and water systems with the open-source energy modeling system integrated framework, researchers combine data from national and international sources such as the International Energy Agency, Food and Agriculture Organization, and Organization for Economic Cooperation and Development. The model spans the period from 2020 to 2050, utilizing detailed assumptions, including a 10% discount rate, 4 seasonal time slices, and capacity factors of 18% for solar and 26% for wind. 2 scenarios, the baseline and the carbon-neutral path, were simulated. The baseline continues current trends with heavy coal and gas use, while the carbon-neutral scenario emphasizes renewables, energy storage, electric vehicles, and large-scale reforestation. All datasets were adapted to Thailand's specific geographic and socio-economic conditions, including monsoon-driven water variation and regional differences in renewable potential. The model then optimizes the cost and efficiency of each pathway to examine how Thailand can achieve its mid-century climate target. The results show a dramatic contrast between the two futures. Under the baseline, fossil fuels still dominate in 2050, with CO2 emissions surpassing 400 million tons per year, renewable power below 20%, and water consumption exceeding 85 billion cubic meters annually. In the carbon-neutral scenario, renewable energy rises to nearly 80% of total electricity, mainly solar and wind. CO2 emissions drop by over 90%, while water use falls by about 40%, thanks to the replacement of water-intensive thermal plants with low-water technologies like photovoltaics. However, the shift demands consistent investment. Solar energy alone requires more than $20 billion annually by 2050. Land use becomes another key factor. Installing vast solar farms could occupy 2 to 4% of Thailand's farmland, making integrated approaches, such as agrivoltaics, vital to balance food and energy production. The findings provide actionable guidance for Thailand's sustainability strategy. Achieving carbon neutrality is technically and economically feasible, but only through coordinated policy. The study recommends interim emission reduction targets, 40% by 2030 and 70% by 2040, supported by green bonds, carbon pricing, and long-term power purchase agreements to attract private investment. Land-based carbon strategies should prioritize degraded or marginal areas for reforestation and involve community participation. At the same time, developing smart grids, expanding rooftop solar installations, and enhancing energy storage systems are crucial to ensuring energy security and flexibility. These steps would allow Thailand to align its national goals with global climate responsibilities under COP29.